In today's rapidly evolving technical world, how do you best focus your learning to truly excel? That's really the core of what we're digging into today.
Exactly. We've been looking at this fascinating discussion among software engineers.
Right. They're debating the best path forward.
Yeah.
Deep specialization in a niche or, becoming more of a versatile full stack developer.
And this isn't just theory, is it? It's grounded in their actual real-world experiences, what they're seeing out there.
Yeah, absolutely. And it's totally understandable to feel a bit, well, maybe overwhelmed by the sheer volume of stuff in software
Oh,
development.
for sure. So many technologies, methodologies. It's a lot.
So our aim with this deep dive is really to explore these different viewpoints.
Pull out the most valuable takeaways, maybe, and help you clarify your own approach to learning your career growth.
Exactly, wherever you are on your technical journey right now.
We've got this collection of really candid thoughts, actual engineers sharing their journeys, their opinions on the specialization versus full stack question.
Our mission: unpack their arguments, find some surprising insights, and ultimately help you get a more informed perspective on this whole debate. It's a big one in the tech community.
Definitely. Okay, so where should we start?
Okay, let's dive right in. One of the first things that really sparked a lot of reaction was an analogy. Someone compared software engineering disciplines to medicine versus baking.
Ah, yes, that one. And what was fascinating was how quickly others jumped in to challenge it.
Right. The idea was, I guess, that the difference between, say, front end and back end is as huge as a doctor versus a baker.
But the overwhelming feeling from other engineers was, well, that's just not quite right.
Yeah, the disagreement seems to boil down to this. While the specific tools, the ecosystems might differ,
You know, JavaScript on the front end feels different from back end work, sure.
but the fundamental engineering principles, they often have a lot more in common than that analogy suggests.
It's not like they're entirely different universes, the core thinking, the problem solving.
The logic, yeah. It often stays surprisingly consistent across different software domains.
So it's less about completely different professions, maybe more about applying those core principles in different contexts.
Exactly. And linking this to the bigger picture, it really pushes back on the idea that specializing deeply makes a full-stack engineer somehow a lesser expert.
Right. Just because someone has broader skills doesn't mean they're less competent in any one area necessarily.
And some interesting examples came up here. People mentioned folks like Jade Wilson or the Prime
As like shining examples of brilliance in really specific fields. Totally valid.
But the counterpoint was key. Are these exceptional people the only way to be highly competent?
And many argued, based on their own careers, absolutely not. There are tons of highly skilled devs working across disciplines.
So while those examples show the power of deep specialization, it kind of begs the question, is that the only path?
Which leads us nicely into the experiences of engineers who've deliberately gone for a multidisciplinary career.
Yeah, we found this really compelling story from an engineer who's worked in an incredible range of areas.
Like what?
Okay, get this. Embedded software, data engineering, high-performance computing, AML, safety-critical systems, and both back-end and front-end.
Wow, okay. That definitely gives you a long-term view.
And they made the point that over, say, a 30-year career, you basically get multiple 5-year deep dives.
Allowing you to gain real expertise in several different domains over time. It makes sense.
It makes you wonder what drives those shifts, doesn't it? Is it pet projects sparking interest?
Or just being in the right place for the right opportunity. Or maybe a bit of both.
Well, their personal story was quite telling. Started in railway software from a university project,
Okay.
then used their C++ skills to jump into embedded systems, then finance. Later, a passion for AI led them there,
Right.
and eventually, combining Python and ML with their software engineering background, opened doors to data engineering and HPC.
So what's the surprising bit there?
The big takeaway was, yes, technical skills open the doors, definitely. But domain knowledge, understanding the specific field, was often the real key in each role.
That's a crucial point. It's not just the language, it's understanding the problem space.
Yeah. And this connects to another really powerful idea that came up, the snowball effect of knowledge.
Ah, I like that. Explain that one.
The analogy someone used was like, my first year I learned one thing. 10 years later, I learned a tad more than 10x.
So learning compounds builds on itself over time,
Exactly. Like a snowball rolling downhill, getting bigger, faster, harder to stop.
which suggests that learning across multiple areas over a long career isn't just doable, it's almost natural. if you keep learning.
Yeah, if you stay curious. Okay, let's shift here slightly. How does team structure fit into this? Siloed teams versus more full-stack teams.
Right. How does it affect actually getting stuff done efficiently?
This is where you see the real-world impact, I think. The bug ping-pong scenario someone described.
Oh, yeah, that painted a picture, a bug just bouncing between front end and middle tier.
Each team blaming the other. Huge waste of time and effort.
Yeah, frustrating. And it leads to product managers sometimes having to act like, what was it, technical QA?
Just to figure out where the problem actually is.
Now, this isn't saying specialties are bad. For really complex, specific tasks, you absolutely need them.
Of course.
But the argument is that having that broader, full-stack understanding within the team can really smooth out ongoing support and maintenance.
Makes sense for many scenarios.
Mm-hmm.
Maybe less so for very specific roles like, say, reporting or pure integration work.
Right. And it's worth saying again, having different skills doesn't make anyone lesser. It's just a different approach.
Totally agree. But this whole discussion takes a really fascinating turn when you throw AI into the mix.
Ah, yes, the AI factor. This was a really thought-provoking thread.
The idea that AI tools might soon handle a lot of the actual coding.
It forces you to reconsider the long-term value proposition of being super specialized in just writing code for one specific thing, doesn't it?
It really does. If AI can automate many of those specific tasks.
Then maybe the ability to connect different areas, the generalist's view, becomes even more valuable.
Could be. Generalists might be better placed to leverage AI effectively, see the bigger picture.
It's a strong possibility. Which brings us back to defining full stack. What do we actually mean by that?
Good question. Because it's not just knowing, say, React and Node.js, is it?
No, the discussion clarified it's more about broader engineering disciplines, not just a specific tech combo.
And everyone acknowledges deep specialization will always be needed for certain things.
Like super low-level machine code or really intricate Java memory optimization, highly specific stuff.
And there's definitely pride in that deep knowledge, right? Recognizing those unique, hard-won skills.
Absolutely. But that contrasts with the idea that full stack isn't about being the ultimate master of every single detail everywhere.
But more about having a really solid, comprehensive grasp of how all the pieces fit together.
Exactly. Understanding the whole system.
Someone used a great analogy about the library expert.
Oh.
Someone who knows one specific library inside out might suddenly become less valuable if that library gets a massive overhaul or replaced.
Right. Their deep knowledge is tied to something potentially temporary.
And the perspective offered was that the true experts might be the people who actually create the tools.
Not just those who get really good at using one version of them. That's a sharp point. Adaptability is key.
It really is. And interestingly, the conversation even touched on the history of full stack.
How so?
Well, the point was made that many early computer science pioneers were basically full stack because they had to be.
Out of necessity.
Yeah. Early computing was so complex, spanning hardware right up to GUIs, that practitioners needed a massive range of skills.
So being a generalist wasn't really a choice back then. It was just how it was done.
Pretty much. Fast forward to today, and you still see the value of that multidisciplinary approach in areas like consulting.
Definitely. We saw an example of a consultant working across, well, a lot.
Front-end like Angular and React, back-end in Java, C#, Python, AI integration, custom ML models.
Infrastructure as code, observability, databases across different clouds. That's broad.
And for anyone listening, maybe less familiar, infrastructure as code. What's the gist of that?
Oh, good question. It's basically managing your servers, networks, all that computer infrastructure, using code and definition files instead of manually clicking buttons or plugging things in. Automation, essentially.
Got it, thanks. So this consultant's experience really highlights the benefits, right?
Yeah, understanding the different pieces helps you choose the right tool for the job, control costs better.
And even mentor others more effectively, seeing the whole picture.
Plus, that kind of broad experience seems increasingly vital for leadership roles, especially in teams with diverse skills.
True. But the discussion also acknowledged a very real challenge. The mental tax.
Context switching. Yeah, that's a big one. Constantly jumping between different technologies, different ways of thinking.
It takes a toll, doesn't it? Well, some people thrive on that.
It's definitely not for everyone. There's a cognitive load involved in keeping all those different mental models active.
Which kind of leads into the range argument.
From the book, right. The idea that easier communication and information access reduces the need for hyper-specialists.
Exactly. And increases the need for generalists, the glue people, who can connect different domains.
Understand the interfaces between things.
And the thought is that AI might just accelerate this trend even more.
Making specialized knowledge easier to access so the value shifts to synthesis and application across areas.
Potentially. Plus, innovation often comes from that cross-pollination of ideas between fields, doesn't it?
It really does. It challenges that old saying, jack of all trades, master of none.
Because often, by the time someone is a jack of all trades, intentionally, they've actually mastered several areas.
It's not just superficial knowledge. It can be deep knowledge in multiple related fields.
Though we did hear a more cynical take as well.
Oh, what was that?
That maybe the push for full stack is sometimes just companies trying to save money.
By not hiring dedicated infrastructure teams, you mean?
Yeah, that was the suggestion. An interesting angle.
It is, but you could also argue there are benefits beyond cost, like a more adaptable team that understands more of the system.
That's a fair counterpoint, which led to an interesting idea about redefining full stack.
How so?
That maybe it shouldn't mean mastering everything, but rather deep fluency within a specific stack of related technologies.
Ah, so proficiency within a defined ecosystem, whether that's front-end, back-end, infra, or a mix.
Exactly. Moving away from just front-end versus back-end labels and focusing on competence within a cohesive set of tools.
That makes a lot of sense. And this generalist versus specialist thing also seems to play out differently depending on the role, right?
Yeah. The observation was that a generalist's broad view is often great for leadership. Seeing the big picture, understanding different teams.
Well, a specialist's deep dive is often better suited for those really hands-on technical operative roles.
And the key point, both are absolutely necessary. They complement each other.
And company needs change too, don't they? Startups might lean generalist early on.
Wear multiple hats, adapt quickly. While more mature companies might bring in more specialists for focused tasks.
But ultimately, you probably need both for long-term success.
At the end of the day, isn't the core job of an engineer just problem solving?
Fundamentally, yes. The tools, the languages, they're just the means to an end.
A truly effective engineer isn't defined by knowing Java or Python, but by their ability to analyze a problem.
Break it down, choose the right approach, the right tools, and solve it effectively. That's the core skill.
Which brings us to some of the external factors influencing this specialization decision. It's not always just personal preference.
True. Things like the job market in a specific country, salary expectations, they definitely play a role.
The discussion raised some interesting hypotheticals, like what if software paid the same as, say, driving a bus or being a doctor? Would career choices change?
It makes you think.
Yeah.
And it highlights how intense software engineering often is. It's rarely a clock out and forget it job.
Constant learning, always problem solving, often outside standard hours.
Which touches on the time investment needed to become really good.
Someone mentioned the idea of a 3x engineer. What does that usually imply?
Generally, it suggests an engineer who's significantly more productive, more impactful than average. It's usually a mix of deep technical skill, great problem solving, and the experience to make good decisions fast.
And that doesn't just happen by working 9 to 5, does it?
No, it's built over years of experience. A CS degree gives you a foundation, sure, but the real learning happens on the job.
And while experience makes things feel more manageable.
It doesn't mean the job itself is inherently easy. Some tasks might become less challenging, but the field keeps moving.
It's also really important to remember that people are different, right? The ability to maintain expertise across multiple areas varies hugely.
Totally. What works for one person might be completely overwhelming for another. Broad generalizations aren't super helpful here.
And the specializations themselves aren't static either, are they?
Not at all. They can vanish, change drastically, new ones pop up.
Which just underlines the need for continuous growth for everyone in the field, specialist or generalist.
You have to keep adapting.
The conversation circled back to that brain surgery analogy briefly.
Right, the idea that you want a specialist for critical tasks.
Which is valid for brain surgery. But the point was, most software development doesn't have quite the same life or death stakes.
Thankfully, no. Which brings us back to the definition of expert.
Traditionally, it means very deep, specialized knowledge in one area.
Which, logically, means you can't be an expert in everything.
That's a key distinction. A full-stack dev might know a lot across many systems.
But maybe not have that same incredibly deep, narrow focus as someone who spent 20 years on just one specific compiler optimization, for example.
The discussion even brought up the recruiter's viewpoint.
Ah, the practical side. Recruiters might not always have the technical background to see the difference between deep specialization and broad competence.
Yeah, there was this kind of shared wish that recruiters understood that languages are often just syntax.
And that the core problem-solving skills are much more transferable than they might seem,
Understanding that could lead to better hiring, maybe? More nuanced.
potentially. I liked another analogy someone used, software development as different genres of writing.
Oh, like writing novels.
Yeah. The basic principles of storytelling might be similar, but each genre, sci-fi, romance, mystery, has its own style, conventions, nuances.
That makes sense. And someone else made the point that front-end code,
It's basically back-end code, just with the added complexity of the UI.
yeah, strip away the user interface, and the logic, the problem-solving underneath, is often pretty similar. It blurs those lines again.
So where did the conversation seem to lean in the end?
Well, there was a pretty strong argument emerging for the growing importance of the generalist engineer.
Especially with AI potentially handling more specialized tasks.
Exactly. There was even a sense of maybe unease among some who focused very narrowly.
A concern that deep expertise might become less critical if AI can augment it easily.
Yeah, that feeling came across. And interestingly, vibe coding was mentioned briefly.
Vibe coding. How does that fit in?
Well, the idea, I think, when used responsibly, is that if the problem is well understood and the tools are familiar,
The coding becomes more intuitive, less reliant on super deep specialized knowledge.
kind of, in those cases, a good generalist might be perfectly effective without needing that extreme depth.
Interesting. So it potentially lowers the bar for needing extreme specialization in some contexts.
Maybe. And finally, we heard from someone with like 26 years as a generalist.
And they found value in it.
Immense value, being able to adapt, jump into different teams, contribute even with unfamiliar tech.
Quickly getting up to speed enough to offer useful insights. That's a powerful skill.
Definitely. So, okay, let's try and wrap this up. We've covered a lot of ground here.
We really have a whole range of perspectives on this specialization versus generalization question.
It is clear there's no single right answer, is there? The sources show valid viewpoints on all sides.
It really depends on your individual goals, how you like to work, the industry dynamics. It's complex.
So bringing it back to you, the listener, we really hope considering these different arguments helps.
Thinking about these experiences in the context of your own career, your own learning style.
It can hopefully empower you to make more informed decisions about where you focus your energy, how you want your career to look.
Absolutely. And maybe we can leave you with a final thought to chew on.
Let's do it.
Okay, so here it is. Given the rise of AI, the increasing interconnectedness of everything, will the future ultimately favor deep vertical specialists?
Or will it favor those who can navigate and connect diverse domains, the generalists, the integrators?
What approach feels most aligned with your curiosity or long-term vision in this ever-evolving world of software?